All right, let's get some reviewing done. First thing is radical expressions and also rational exponents. They just kind of go together. Um, we want to be able to go from one form to the other because sometimes it's easier to simplify in one form than it is the other. And just they speak to us in different ways. So if we wanted to write this as an exponent, we have to realize that this number is the root and this 7 is the power. So they both become a part of the exponent, but roots are the denominators of these fractional exponents. So if it was just m to the 7th, then there is no root, and so it would be 7 over 1. But as soon as we have a root, there's a number under here that isn't 1. In this case, it's a 7 or a 6, and a 7 goes on top. That's how you write that as an exponent. Something that you have to be careful about with number 2 is that everything under here is under the root. It's all being raised to a power. It has this 5 on the outside of the parentheses to show that not just the 10, but the x as well, both of those things are being raised to the 5 over 2 power. The way I know it's a 2 is because there's no number written out here. If it was a 1, it would be just to be 10x to the 5th. There would be no root. So if there's a root, we know for sure that it's at least a 2. So that's that one. Going the other way, I'll knock out number 3. So again, the bottom of that, that's the root. So that's going to go here. This is going to be a cube root. Everything under here is under the root. So the 2 and the r are both being rooted, and then they're also being raised to the second power. There's a couple ways you could write this. You could write 2r to the second power, and then put all of them under a cube root. Either of these would be correct. All right, let's do a little simplifying here. I'm going to do the evens and leave the odds. Okay, so notice in the order of operations here that every single part of this is being multiplied. Okay, so there are no other operations that we can do, like n to the 4th. We can't do that exponent because we don't know what n is. So we can't raise it to the 4th power. So really, we're just collecting like terms. I'm going to look at the coefficients. -2 times 2 is -4. Now I'm going to look at, let's do m's next. There's only one m. It's an m cubed, or there's only one term with an m in it. And then there's n to the 4th and n to the 3rd. So if we multiply those together, we're just going to add up these exponents. So that becomes n to the 7th. And that's as simple as we can make it. Number 8. There's quite a bit going on here, but we can simplify our lives by again recognizing the only operations that can be done here are there's a bunch of multiplying, there's some division being done, and there's some more multiplying down here. So in the order of operations, all those things are equal. We can just do them in the order we come to them, or whatever helps us consolidate some terms. For example, -3 divided by -3 is 1. So essentially those will divide each other out. They equal 1. Now we can move on to the m's. We've got an m to the -1 over an m squared. There's a lot of ways to think about this. You can recognize that this is a negative exponent, and so it's going to come down here, and this would become m squared times m to the 1st. So remember, if the exponent is negative and we bring it across this fraction line, either to the denominator, or if it was in the denominator, moving it to the numerator, either way, the exponent becomes positive, not the term. It's not that we can take a negative m and turn it into a positive m, but we can take an m to the negative exponent and turn it into an m to the positive exponent. So that becomes 1 over m to the 3rd. Let's keep track here. So in our denominator, we've got an m to the 3rd. Real quick, another way that you can think of this is if you've got a fraction with the same base in the numerator and denominator, you just subtract the exponent. So that's -1 minus 2. That's m to the -3. It is in the numerator, and then we would move it to the denominator, and it would become an m to the positive 3. Knock that out. I see this way go wrong a lot because people don't know where to put it, numerator, denominator. Always in the numerator. Okay, then we can do the same thing with our n's right here. So instead of thinking of it as an n to the -1 in the numerator, I'm going to move it down to the denominator. It's going to become 1 over n to the 3rd, n to the 1st, which is just n to the 4th. We add those exponents. So going back to the original fraction, the 3's canceled out right away. That has nothing to do with whether we move something to the numerator or denominator, just coefficients, and they divide out. Now look, everything up here has a negative exponent. That's why everything vacated the numerator and went down to the denominator, left us with just a 1 in the numerator. So that 1's just like a placeholder, 1 out of this. And number 10 will be the last one for this video. We've got a whole bunch of stuff in these parentheses being raised to the 4th power. This, we're going to use the power rule because they got powers to powers. In the parentheses, though, we always want to check, is there anything that I can simplify? Can't multiply these because they're not, they don't have like bases. X and Y, can't multiply those. So I'm just kind of forced to go ahead and raise everything to that 4th power. That's 3 to the 4th power. That's x squared to the 4th power. What's x squared to the 4th power? Well, it's x squared times x squared times x squared times x squared. That's a complicated way of saying, you know, we'd add all those up. That would give us x to the 8th. So 3 to the 4th, x to the 8th. And then let's actually use the power rule here. The power rule says if you have an exponent raised to an exponent, you just multiply those exponents and it becomes y to the 8th, 2 times 4. That is not the answer, but I put a box around it. I don't know why. I mean, it's almost the answer, but we do know that 3 to the 4th power is just a number. It's 3 times 3 times 3 times 3, which is 81, x to the 8th, y to the 8th. That's your final answer. All right, I will stop this and make another video for the next one.